Hello everyone, this is Jeff Krob. I'm the designer and programmer for WINGRIDDS. WINGRIDDS is a program that's used, well, first of all, WINGRIDDS stands for Windows Gridded Interactive Display and Diagnostic System. WINGRIDDS is used to ingest and display GRIB data. And GRIB is a World Meteorological Organization data standard which stands for gridded binary data. Gridded binary data, or GRIB data, is the data format that's used for all of the forecast models that output all the individual forecast hours through the forecast cycle that they use, and it's always is packaged in gridded binary data. And so WINGRIDDS ingest that data and also observation data. WINGRIDDS can also read the METAR, synoptic, RAYOB, grid point buffer data, and it can also ingest that and display that as well. It's essentially it's a forecaster's tool for providing interactive access to the gridded binary data that's output from the meteorological data that's output from the meteorological forecast files or forecast models. And it's used for forecasting, domestic forecasting, and international, like aviation forecasting, things like that. The different gridded binary data formats are the regular GRIB forecast file, which is pretty much the whole forecast domain of the model, forecast model. You also have what's called WAFS GRIB data, which is unique to WAFS stands for World Area Forecast System. This was designed back in the 80s and 90s to provide the third world countries and facilities that don't have a large established telecommunications system to allow them to download smaller versions, subsets of the global forecast areas. And so this is a little screenshot from the WINGRIDDS Users Manual, WINGRIDDS Users Guide, that shows the WAFs global area subdivisions they subdivide the world into 8 sectors, 4 in the northern hemisphere and 4 in the southern hemisphere. There are assigned numbers as well as letters, and this shows the demarcations of the different octets, which goes like from 330 degrees east to 60 degrees east, so that crosses 0 degrees longitude, 60 to 150, 150 to 240, and of course that crosses the international date line out in the Pacific, 180 degrees, and then from 240 to 330. So one of the things that makes this unique is that the way WINGRIDDS handles it, the ingest program that's dedicated to WAFs can take these individual octets and these individual sectors and glue them back together. And so that's a unique processing function, and so that's why it's handled differently than the regular gridded binary data. WINGRIDDS can also handle the ensemble data, all the different model members that is associated with ensemble forecasting, as well as the probability, ensemble probabilities, which is associated with the precipitation. And so that's a unique thing. And also handle what's called MOS GRIB data, which MOS stands for Model Output Statistics, which is something that's unique to that the National Centers for Environmental Prediction puts out mainly across North America for model statistics, for temperature, for precipitation, and things like that. The ECMWF WAFs are similar to the World Meteorological, typical similar but different, that ECMWF does. Theirs are also in 8 octets, but theirs are aligned slightly differently. Those go from 0 to 90 degrees longitude, from 90 to 180 longitude, from 180 to 270, and from 270 back to 0 again. And so, but the WAF's ingest utility and conversion utility will handle these as well and can glue these together as well. And so, say for example, you were only interested in the area around North America and South America, you do the sectors of I, J, and M and N, and you program those to ingest, and it will glue these 4 sectors back together again. And so that's something that's unique. The WINGRIDDS icon is a yellow W, and so you just double click that and let's get it going and show some things that it can do. For these demonstrations, we'll be using version 5.13, which is already out. And so everything that 5.13 can do, any future versions can do as well. If you notice, it's broken up. You have your display area, you have a command line which you can type in the commands to display the information. WINGRIDDS also comes with a ability to build command macros or batch files, which is similar to the Windows or Unix scripting. And so this already comes, it's not delivered as a clean slate. It comes with up to, I think it's around 1,700 command macros that have already been predefined and included in the system to do a whole variety of different projections and manipulations of the data to display a variety of different things. WINGRIDDS itself comes with with a very rich command set. I think over 300 commands for doing a variety of different things, and we'll get into those later. And also, WINGRIDDS comes predefined with up to, I think it's around 2,800 download scripts for downloading grid data into the system and then converting it over to the data format that WINGRIDDS uses. WINGRIDDS does not work on grid data directly. It has to be converted, and so to the WINGRIDDS data format. And so we'll get into that in other dedicated videos for that. And all of these series of videos are going to be going into the operations of WINGRIDDS, like I said, the ingest and the conversion of data to the WINGRIDDS data format, how that's done, the things to look out for, the details about how that process is done, and then getting into the operations of WINGRIDDS itself, showing the command macros, some videos dedicated to doing cross sections and time sections, getting deeper into things like the contour color filling applications and commands for the climatological aspects of the data. WINGRIDDS has both a 30-year and a 60-year climatological database that it references for doing the climatological mean and deviations from the mean. And so it can also do like Q vectors, it can also do like stream functions and velocity potential. It can do animation, and it can do a whole variety of different things. So we'll be going through, and there's also a very powerful command application, what's called an alias data file, which you can actually build some very powerful displays using the alias commands. And all of this is spelled out in the WINGRIDDS User's Guide, but these series of videos are going to be a little helpful video hand-holding, if you will, to show you what WINGRIDDS can do. Totally make it easier to utilize WINGRIDDS and to show you the variety of things that WINGRIDDS can do. So first of all, let's open up a data file. And all the data is stored in the grid data directory. If you notice, WINGRIDDS is always in the off of the C drive or off of the root directory. It's not in the program data or program files section that WINGRIDDS defaults to. And so we found out that trying to store WINGRIDDS, install WINGRIDDS in those directories causes some reading and writing protections and permissions issues that WINGRIDDS enforces, or excuse me, that Windows enforces. And so it's better just to keep it in the root directory of the C drive, or if you want to put it in the D drive or some other drive, it doesn't matter, but just keep it in the root directory. So you show all of these that I've collected data files. They're shown by month, and then it shows the date time group of that model run, and then shows the model name, GFS or NAM or the CFS, which is the climate forecast system. And then after that, it shows the last three numbers are the grid projection associated with that data file. National Centers for Environmental Prediction has about 255 different model projections, different grid resolutions, and so that's that three-letter at the end shows. But for right now, let's look it up a NAM data for national or North American model. That quick model display was shows you what the model data was projected at. Every gridded binary data has a model projection associated with it, because you have to be able to map two-dimensional data to a three-dimensional grid or to a three-dimensional globe. And so since you in order to do that, of course, a North American model, something centered over North America, would not use traditionally a latitude-longitude grid that would be associated with a global model. And the three primary projections that are used are the equatorial lat-long grid, which is centered across the equator, the equator, which is centered across the equator, and that's usually, like I said, reserved for the global models. And the farther away you get from the equator, the more distortion that there is towards the poles. And so the poles are spread out. The pole is spread out, be stretched across the top of the grid. And so your latitude longitude lines are shown as squares. So you get your least amount of distortion across the equator up to about 30 degrees latitude, north and south of the equator. The next popular projection is what's called Lambert conic conformal, which is, if you will, visualize the globe and you have a cone descending down across the northern hemisphere or coming up from the southern hemisphere, but across the northern hemisphere, and the point of the cone is at the pole, and then it spreads out across to the equator. You get your least amount of distortion between 30 degrees to 60 degrees of latitude, and so this projection is reserved mainly for the mid-latitudes. Then you get, like I said, increasing distortion towards the pole or down towards the equator. And the last projection was called the polar stereographic, and that is, if you will, visualize looking straight down at the pole from space. The pole is a point. Your latitude lines are rings around the pole spreading out towards the equator, and your longitude lines are like spokes in a wheel, radiating out away from the pole towards the equator. And so you have your least amount of distortion from about 60 degrees north latitude up towards the pole itself, up to 90 degrees, and then you have increasing distortion as you head away towards the equator. So those are your three main projections that are utilized for your gridded binary data. The NAM, being a North American model, they project everything using the Lambert conic conformal. But when WINGRIDDS opens up a data file that looks at the navigation that's embedded into it, and so it draws the map that is associated with that projection. And then it lists all of the data parameters that are associated, that are grouped into that data, to that forecast hour. And we can look here. This is towards the middle area of the atmosphere. We have your numbers listed here are your pressure in millibars, and then you have your data parameters associated with that. So you have dew points, you have heights, you have omega, which is vertical velocity. You have your humidity, your moisture, showing both relative humidity, specific humidity. Then you have your temperature, and then you have your wind, which is always represented in grid, called U grid and V grid. U grid is your north-south wind. V grid is your east-west wind. And so whenever you type in the command you want to see the wind or something associated like that, it will look in and search for the U grid and the V grid parameters and create a wind barb of direction and speed associated from that. We can progress on down. You have your surface parameters, and then you have some boundary layer things. If it has a prefix of a B, the level that's associated with the boundary layer. If you have, say, M, those are associated with height above ground level. Your S, those are what's called, those are associated with your sigma levels. Your Y is associated with hybrid levels. And then you usually have your like max W, which is your layer of max wind. So you have your heights, your pressure, and then the wind that's at the max wind level and things like that. Sometimes the tropopause is included in here. Sometimes potential vorticity levels would have a P and then a plus or minus the number, and that's your potential vorticity levels above and below the tropopause, things like that. So let's jump on in. Yeah, let's do some, shows you some basic things that WinGrids can do. Let's show, like, say, but first, before I get ahead, whenever you open up a data file, it defaults. WinGrids has some defaults that it starts at, and so your default level is 850 millibars. Your default layer, which is 2 heights, which would be default is 1,500. Your default forecast hour is 0. Your default forecast hour time span is from 0 to 24 hours. Of course, this is file number 1. WinGrids can open up to 99 data files at the same time, and so it can utilize, especially useful if you're comparing different forecast model runs, or if you're comparing like ensemble data. You can get up to like 20 members per ensemble run for both the GFS, for the Canadian models that they run their ensembles, the ECMWF, if you have access to that, they have about 20 members that they run. And so you can, if you ingest all those members and you open them up, they can get quite busy. But WinGrids can open up to 99 data files at the same time. The model name, the model ID is the NAM, the North American model. And here's some parameters. The time of the model run was 19 April 2016. Shows this is a plan view, and it shows a data thinning of every 4th grid point, and I'll show you that later, that you can adjust that. And then of course the name of the data file itself is here. So let's show some basic stuff. Let's show like HGHT. Let's show some heights. And this is how the WinGrids displays the heights. It has your contours. It does an automatic contouring of the data, and it has a contour interval that it will choose automatically. You can redefine that if you wish. I'll show you that. But your contour labels are always in whole integers. There's no floating point, or there's no exponential notation, and that can get kind of confusing for the new user, especially for things like very small values like vorticity or for vertical velocity, mixing ratios, things like that. But it will always show the data value in a whole integer number. Across the top of the screen, it shows some statistics of the data that's been plotted. The first number here is the minimum data that it was in the field of view. The next number is the maximum of the data that was in the field of view. The next number is the mean, which is the average between the two, the maximum and minimum. And then you have your standard deviation, which is 49.26. And you can overlay data. For first of all, this is an example of a scalar data. You can also show like a vector data, like wind. So let's show that. Type in wind. It defaults to an arrow representation of the wind flow. The longer the arrow, the faster the wind flow is, and the shorter the arrow, the slower the wind flow is. We can also show these in, you can either show arrow, you can show wind as an arrow representation, you can show it in barbs, or you can show it in streamlines. And so we can change that. So BARB, show wind in the barb flow, barb representation, and that's what that looks like there. You also do streamlines, so the wind STRM, and so it can show wind in the streamline flow. And these these representations are, these data, whether it be arrow, barb, or streamlined, is what's called a flag. And so it will shift the mode of the wind to show in streamline or in barb or in arrow until you command it to do something else again. So it will stay in that mode. But I prefer the arrow mode, AROW. So we'll put that in arrow mode. And so we can show wind, and we're back in arrow. WinGrids can also overlay data. So let's do HGHT/wind. The slash says to put both of those together, and that's what it has done. So do the heights and the winds together. Let's show something a little more complex, and I'll show you something. Go HGHT/wind/temperature/RELH for relative humidity. And I'll learn to type here. I'll learn to spell here pretty soon. Let's do that again. So HGHT/wind/TEMP/RELH for relative humidity. And this is an example of what WinGrids will complain if it doesn't find a parameter or something that was commanded. So the HELH, which of course does not exist, at 850 millibars at 0 forecast hours was not found. Try again. But we know it's actually spelled RELH. And so you can see here that all 4 parameters have been created and displayed, and they've all been assigned different colors. This color band down along the bottom of the screen is your color selection that WinGrids uses when it's overlaying a variety of different parameters. And this is what it defaults to unless you override it and define it to show something else. So let's go over this. Number 1, you can go to the command history button here, and it will show you the sequence through the commands that were entered. You notice I typed in height, wind, temp, relative humidity. WinGrids evaluated and executed this command string from, I typed it in from left to right, it evaluates from right to left. This is very important to keep in mind. If you want to show certain parameters and certain values and certain diagnostics with certain colors or in certain ways, you have to make sure, or at certain levels, you have to make sure that you type them in the order and make sure that it gets displayed in the way that you want it to be displayed. So WinGrids went through, saw relative humidity number 1, and it assigned it color number 1, which is purple. So all of the purple contours on here are relative humidity. The next one was temperature, temp. That was the second command, and the second color is red. So all of the red contours on here are temperature. The third command was wind, and the third color is like an off-white or a pale white. And so all of your wind barbs and wind arrows is in that color. And then your last command was height for the heights, and that's the fourth command. The fourth color shows yellow, and so heights was plotted in the color yellow. You can override that. Let's erase that. Let's erase that. And say we want to show the heights in, or the temperature, let's say, in color number 4. So we go TEMPCLR4. That will force color 4 to be evaluated for the temperature. And there we see temperature is being shown with the color, with the fourth color there. We can also change the contour interval. Say right now WinGrids will default to a 5-degree contour interval. This is all, of course, in Celsius. So let's go TEMPCLR4, contour interval of 2 instead of 5. And there we have now a contour interval of every 2 degrees instead of every 5 degrees. It shows the negative values and positive values. And one of the other things that WinGrids can do, let's put that back up. We can also differentiate using dashes or dots or dash dot or different patterns to make other contours stand out. So let's let's dash the negative number, anything negative below 0. So there's a special command DNEG for dash negative, and there you can see that all the negative values have been dashed, and over here in the northeast and in the northwest. So that's something WinGrids can do. These buttons up here, if we want to, we see that, say we want to overlay, instead of typing in the number or the slash or the ampersand to overlay, we can also press that button and then type wind, and it will overlay the wind over top of that. But since the wind was the second command, temperature was forced to color forward. Wind then gets assigned color 2. So that's what happened there. These next buttons across here, we can increment the forecast hour, and if you hover the mouse over that, it will tell you what it does. So we can increment the forecast hour, and if you look down here at the bottom, went from forecast hours 6 to 12. Click it again, goes from 12, or from 6 to 12, and then from 12 to 18, or we can go backwards, 18 to 12 to 6, back to 0 again. We can change our levels also. We can increment or decrement the grid levels. And so if we increment the grid level, we notice we're going higher up in the atmosphere, so this number, the millibar number, is getting smaller. Go from 850 to 825, 825 to 800, and it will step to what the pressure levels are available. It won't just go like every 5 millibars or every 50 millibars or every 25. It will see what the next available pressure level is, or isentropic level, or height level, depending on what mode that you're in. Like for isentropic levels, since those are not packaged in the grid data, it will step like every 5 degrees or every like that. But if they're like for pressure levels, if they're included in the gridded binary data, in the grid data, in the data file, then it will see what the next one is available and it will step to it. If you can decrement, you'll go down in pressure, so it means, or down in the vertical level, so your pressure levels will get higher. And then these next buttons are decrement or increment the forecast file. If you have multiple forecast files opened, then it will step through those. Let's erase the map. For some simple map navigation, you can use these buttons to zoom in or zoom out. You can pan to the east, or you can pan to the west, and the same thing for going north and south. For navigating around, there are also commands for that. That's the area command. But those area commands can also be incorporated into the command macros. I'll show you an example. I know that ECUS. That is a command macro that has the area command to focus in on the east coast of the US. Now, the way that WinGrids differentiates between a regular command to grab a scalar or a vector out of the data file, or to execute a command macro, all command macros end in a period. So ECUS will move the navigation to the east coast of the United States. I also know that USMP says to focus on the United States map, which is the full CONUS, and so it will do that. WinGrids can do plan views, which is what we were doing, or it can do cross sections, or it can do time sections. So we can show an example of a cross section. When you click on that, it shows your left latitude longitude point. It also shows your right latitude longitude point. Since you're doing a vertical cross section through the atmosphere for a specific forecast time, these are defining the start and end points of that cross section. These are adjustable and can be configured by the user to wherever you want them to be. You can either type the numbers in here specifically for that point. You can go through, look up predefined areas. You can type in the station IDs for the start and end point if you know that. Or you can do a graphical map selection to draw the line through a graphical area. I'll show you that when we do a video dedicated to the cross-section setups. But for right now, that is how you can choose your points. You can do then for the pressure levels. For the levels, the vertical slice through the atmosphere, you can either have it in preset pressure levels. You can use all of the model pressure levels that the model provides. You can use the isentropic levels if you want. You can use height levels if you want, or you can have a predefined user file that the user has created to set up a predefined area. All of the configuration files that WinGrids uses for things like this, or for defining how the WinGrids works, are all text-based. They're all text documents. There's nothing really encrypted or binary mode or anything like that. So the user can find these, and they're all defined in the user's WinGrids user's guide. But the user can open up like Notepad or whatever text editor that you want, and you can edit these files or create new files if you want. But for right now, we're just going to use the defaults, and you go OK. And so there's your line, and here's your cross section that's been defined. So the vertical coordinate is in pressures, is in millibars. And then that's your y-axis. Your x-axis is in latitude, longitude points through the cross-section. So let's show some data here using an example. Let's show the temperature and the wind. And of course, the wind is in arrows, and that shows your temperature through the cross-section. And that's overlay WSPD for like wind speed. Put your slash there. So that shows the wind speed in meters per second. You can do it in knots. You can do it in miles per hour. Whichever you want. Those are available. And of course, you're showing that the length of the wind vector is proportional to the wind speed. We were talking about the command macros. These are all listed under the products menu selection. And again, this is the out of all of the menus that are available up here, the products is the only one that is user configurable, is user defined. All of these groupings for the command macros are in a text file that WinGrids reads, and it creates this menu from that. And these are all grouped together in things like the winter precipitation, and then you have severe convection, regular quantitative precipitation, QPFs. And we can go down. Like I said, there are like 1,700 predefined command macros that are included. And so we have some that are dedicated to the WAF's grids, but they can probably be used for any of the gridded binary data. Then we have the macros that are dedicated to specific layers, specific levels for the surface, 1,000 millibar diagnostics, 850 millibars, 700, 500. Some AFOS graphics. The AFOS system, just real quick, for those that don't know, reaches way back to like the 1980s and 1990s in National Weather Service offices. These were the precursor to what the AWIPS is, and now AWIPS 2. What they used in the weather forecast offices and for life of me, I forget what AFOS stands for, but it was an old computer system. The graphics were like just basic black and white monochrome line graphics, and were very simplistic, but this was also the terminals that they used to type up the forecast, type up the warnings, and then it was connected to the telecommunication system to send that information out to the public. And so these are some graphics that were recreated for that. Temperature diagnostics, moisture diagnostic, kinematics, like for the wind fields, isentropic analysis, QG diagnostics for like Q vectors, things like that. Farther down, we have some that are dedicated to time sections and cross sections. And so since we have a cross section up here, let's do some demos. So let's show the relative humidity, vertical velocity, and the wind. And if you notice, what pops up here is all of these that are grouped within the cross section. The first 4 letters are the name of the macro file. These were inherited from the previous system, and so originally I could only do 4 alphanumeric characters long. WinGrids now can be up to 10 alphanumeric characters long. But these were all limited to were limited at 4 characters, and so that's where they were staying. So let's do A04B, which is the relative humidity and vertical velocity and wind. So you can either single click on it and hit OK, or you can double click on it. And so that shows the wind and the relative humidity. And now the wind was shifted over to the wind barb mode. And also notice up here at the top it says press enter or click go to, which is the go button, which is over here, to continue, or click stop to stop the sequence. This command macro has 2 parts to it, and so it's pausing to that you can see the information, and then you can progress on to the next segment of the command macro file. So let's go to go, and so that's showing your vertical velocity using the dashed contours. And we can go back to plan mode, and if you notice, as we configure these plan modes or cross sections or time sections, the letter becomes bold instead of grayed out when that is enabled. To disable it, while we got here, we can do CROS and then 1, 2, 3, 4, do 9 nines, and that will remove the cross section configuration. So that has gone back to gray again, and you can't click on it. But let's do a time section. And again, this is very similar to what the cross section was, except for time sections it's only a single grid point. It's not a cross section cut. It's only using a single grid point through the depth of the atmosphere. So this is your latitude longitude line for where that point is at. And the vertical coordinate again is similar to what it was with the cross section. You do a preset pressure levels. You can do all of the model pressure levels, isentropic height levels, things like that, or again a predefined file that you want it to use. But then there's a second portion which shows the forecast times along your x-axis. And so you can either use the preset forecast times, you can use all of the model forecast times, and like say for like a GFS or something, they can go out to like 300 hours if you wish. So it would utilize all of the forecast times for that. Or if you can have a preset user-defined file that you would then enter in. So you enter in whatever letter applies. We'll stick to U for the preset. Hit OK. And so there's the time section. And those are your forecast hours that will read from right to left, that increasing in time through the forecast period. So again, we can do like TEMP/wind. And so it's progressing through, and then it draws the wind barbs, and it draws the temperature through that forecast period. And again, there are some command macros associated with that. So again, let's do the relative humidity and vertical velocity and wind like we had before. So there's your relative humidity, and there's your wind, and then the vertical velocities are dashed in for showing the forecast period. And again, when we up here at the top, when we configured our time section, the T became black, and then when we selected it, it became you have the box around it, so that shows that it's selected. Also over here in the display, you can show it has the check mark next to it that it's been selected. And we can either click to go back to plan again, or we can type PLAN here to go back to the plan view. but it shows that the time section is still active, is still available, and so it's bold in the T. Something else that WinGrids can do is in a group all their own, we can show skew-T diagrams, we can show STUV diagrams, telphogram diagrams, or hodograph diagrams, or we can plot trajectory plots, either forward trajectory or backward trajectories, and we can create BuffKit files. Just real quick, the BuffKit program is a program that was written and created in the Buffalo, New York National Weather Service office, and it was originally a tool that they created to help them forecast the lake effect snows that they experience during the wintertime. These are kind of a unique things in the United States in that area, and so they created this program to help them to forecast those events. And it's the format is similar to like doing a time section. You select a specific geographic point. It will collect the data vertically through the atmosphere and out in forecast time, and then it will write the data file that BuffKit uses, which is unique to that program. It's all text based, and again, once you create the file, you can go in there with a text editor and you can actually read through the data parameters. It's like a bunch of different soundings for every forecast hour, and then there's some other diagnostic data that's created and that's calculated and that's thrown in there. But WinGrids can create that file to be used in BuffKit. They've enhanced the BuffKit program in the years to enhance or to include severe weather forecasting, heavy precipitation forecasting, and things like that. So it's an interesting program to check out, and WinGrids will support the file format that BuffKit uses. But for now, let's look at like a skew-T diagram. You can choose the location, whether it be a latitude, longitude point, or a grid point, X and Y grid point. And let's look at the skew-T, and we'll go with that. And if you notice that location was at Wallops Island Station in Wallops Island, Virginia, that shows the station ID and the ID number for Wallops Island. It shows the latitude and longitude point. It shows the grid XY point. And then graphically it shows all the information. It shows the parcel. It shows the temperature. The lifted parcel is the dotted yellow. It shows the temperature curve. It shows the moisture curve is in blue. Temperature is in red. You have your wind barbs that are color coded for different layers in the atmosphere, and then you have your labels for your lifted parcel level. You have your wet bulb 0. You have your freezing level. You have your most unstable convective layer. If this was like in a warmer parameter or a warmer location, this would look different. Let's do this again. Do display, do sounding, and let's do the station like say Dallas Fort Worth. So that'd be KDFW, and so that changes the location for Dallas Fort Worth. Hit OK. So here's a little bit more of a convective region like before that might see some thunderstorms. So here's your parcel, where it reaches the condensation level, and then it starts progressing up the moisture to diabat. And you can see over here, it shows your CAPE, it shows your convective instability, it shows your lifted index of -6. Got your convective parameters all the way through there. It has some wind parameters like for forecasting storm motion and things like that. It has your thickness, a variety of different thickness listings for different layers in the atmosphere, like for forecasting snow or things like that. Of course, this is all a rain sounding, since your freeze level is fairly high. Freeze level is up to 3,555 meters. A different display, let's do a hodograph for the same location. You notice, well, again, how the wind is, and so we hit OK. And so that draws a hodograph that's representative of that same sounding. Initial information is fairly similar, but then we get to more detailed information concerning the wind. the mean storm wind, or excuse me, the mean wind direction, then the storm motion using a variety of different characteristics, and then your bunker's storm motion for like supercells, Corfiti vectors, the helicity and holicity for whether it be left moving or right moving storms. And these little icons up here are relate to the different values for the storm motion, bunker storm motion, Corfiti vectors, and things like that. So let's erase that. Something else that WinGrids can do is contour color filling. So let's see. Let's show our temperatures at 850 millibars, and how that is again. And let's do a just a basic line-based graduated color, for example. So let's do TEMP CTLG. And so the lines, the contours, are lines associated with the values from minimum to maximum. So as you get towards the colder temperatures, your contours change color in a graduated way. And we can do more like a pattern. TMP, let's see, CTFP for a pattern. That's a little different. A different contour pattern for the different gradient. Or we can do a contour, a fill shows a selected color, so temp CTFC. And so it shows the color contour, and then also shows the values associated with those specific colors along here. Or if we want to just do a graduated color, we can do temp CTFG for graduated. So that kind of smooths that out. Just shows the maximum and minimum. And if we see how that matches up, we can show the temperature again. But let's force that to color 4 like we did before. CLR4, contour interval of 2. Nuts. It didn't overlay. So let's go back to that again. Let's redisplay that again. And let's put our overlay on there like it should be. So that will overlay the temperature onto the gradient like that. One of the other things that WinGrids can do is called animation. It can animate through the forecast hours that are available. So let's do something like HGHT/wind at the 500 millibar level. ANIM, that's the animation command. So the animation command, so like again, it evaluates the commands from right to left. So it will see animation, and then we'll take all of the parameters after that and build an animation from that. So let's watch how that does. It will step through the different forecast hours, everything that's available. It will build the animation. And then once it gets to the end, it puts the animation in motion. And you can see up here that how it's stepping through the different forecast hours. And when it gets to the end, it stops, and then it goes back to the beginning and starts again. And when you start an animation, when you build an animation and starts in motion, that enables this toolbar up here that you can move around if you wish. And these different controls do different things. This increases the animation speed, so as you click on that, you can see the animation is speeding up. And the opposite is to decrease the animation speed. You can see the animation is slowing down. But let's pause the animation. And we have paused at 24 hours, and so we can now use these two buttons to step through forward or backward one frame at a time. We can step through 30, 36 hours, 42 hours, or we can go backwards in time, go back to 24 hours and things like that. And then we put it back into motion again. And all of these buttons you can use back and forth, but if you press the stop button, that will halt the animation, and then that disables it, and we'll put it back into regular display mode. So let's erase the map. And one last thing we want to look at are these buttons here. So we can either do a single panel, or we can do what's called a 4-panel display. So you click on this button, and this will break the main window into 4 separate panels that you can then show different information, like HGHT in window number 1. So let's go select window number 2. This is window 2 here. This is window 1, 2, 3, and 4. So window number 2, let's show the wind. Let's go down to window number 3. Let's say the PMSL, that's the pressure, the mean sea level. So that shows that there. And window number 4, let's show the relative humidity. Let's see if this will work at the 10-meter level. Hey, it works. Cool. So this is basically the surface relative humidity. So you can do things like this. And then we had our time section defined. We're in window 4. So let's put that into time section mode. And let's show the wind and the relative humidity through the forecast hour. So that will do that. Something to keep in mind when you start putting different display options in these. Like if you put time section and you have like a plan view or a cross section view in one of these others, and then you go to change windows, put that back in window 3. This window now is also in time section because that's what's been enabled. So you think you got your plan view there, but you want to show like the wind. Well, hey, you're in time section mode, so that's going to show the wind in time section. You got to make sure your mode changes if you want to display the information in the mode that you want. So that's just a little something to keep in mind here. And then if you want to go back to single window mode, you just click on that button again, and that goes back to plan mode, back to using the whole window. So that's basically what WINGRIDDS is, and then, one last thing before we go. Go exit. WINGRIDDS creates a log of everything that it does, and it's saved under WINGRIDDS.log file, which is in the window or the WINGRIDDS directory. But it will show, starting up here at the top, it will show everything that WINGRIDDS does. It will show the WINGRIDDS starting up. Your open command, you opened up that data file. It'll start showing the statistics of that data file, the navigation information, the map that was drawn. It shows what maps that it was used, and there are high resolution maps that are available. I'll get into that to a different lecture. And then it shows the listing of all the parameters for that forecast hour. And then it starts showing the commands that were entered. The first command was the height command, and it went through, said to get the data, get a scalar data, 850 millibars. The height is the parameter, the 850 is the level. It found it in the data file, and it retrieved that data, and then it contoured and plotted that data. And so everywhere you go through here, all of the commands are saved. And so if you ever have any problems with WINGRIDDS, this is a good file to include along with to show the problem that you had and to show what you did. And so I can kind of recreate and help you troubleshoot to find the problem. It shows the defaults up here, the number of levels for doing your cross section and time section, your defaults for your times, whether it's left to right or right to left. All of those are listed here, and these are, like I said, again, from files that you can go in and modify. But this was a basic overview of WinGRIDS. And like I said, we'll be getting into deeper things in later videos. I hope you enjoyed this, and I hope you found it interesting and informative. And you'll stay tuned for other videos later on. Thank you very much. Have a great day.